Hello everybody and welcome to my next topic on graph theory, that is walks and paths. I'm Suman Matthews. Today we will learn what is a walk, a path, a trail, circuit and cycles, and you will learn a few basic properties in these. And first and foremost, the time-tested way to learn maths is to practice, so you need to practice these along with me. A walk is an alternating sequence of vertices and edges such that any edge or vertex can appear more than once. The number of edges present in a walk is called its length. So here V1, E1, V2, E2, V3, E8, V6 is a walk of length 3 because there are 3 edges, E1, E2, E8. A walk in which no edge appears more than once is called a trail. So we have E4, E3, E2 and E5. This is a trail of length 4. No edges repeated more than once. A circuit is a closed trail. E1, E3, E5, E7, E6, E4. So this is a closed trail because we are starting with V1 and ending at V1. It's a circuit. So basically a circuit is a trail in which no edge is repeated and it is closed. A trail in which no vertex appears more than once is called a path. V1, V2, V5, V3, V6. This is a path. No vertex is repeated more than once. And a cycle is a closed path. V2, V3, V5, V2. This is a cycle. It's a closed path. So remember, trail and circuit, no edges are repeated. Circuit is a closed trail. Path and cycle, no vertices are repeated, and a cycle is a closed path. We come to some small questions. Prove that a path with n vertices has length n minus 1. In a path, no vertex is repeated. So each vertex except the last vertex is followed by an edge. So since a path has n vertices, the number of edges is n minus 1. You can see that this is followed by an edge, so 1. Second vertex is followed by an edge, so 2. So it goes on like this, so number of edges is n minus 1. Show that if a cycle has n vertices, it has n edges. In a cycle, every vertex is followed by an edge. So if a cycle has n vertices, it has n edges. Show that degree of every vertex in a cycle is 2. This is question 3. A cycle is a closed path. So exactly 2 edges are incident on every vertex, 1 edge before and 1 edge after. So degree of every vertex in a cycle is 2. Question 4. If G is a bipartite graph, show that G has no cycle of odd length. Let G be bipartite. So G can be written as V1 union V2, such that every edge in G joins a vertex in V1 to a vertex in V2. So suppose G has a cycle V1, V2, V3, V4 and we come back to V1. Then V1 belongs to V1, V2 belongs to capital V2, V3 belongs to capital V1 and so on because it is a bipartite graph. So the last vertex V1 will belong to capital V1 again. So the cycle cannot be of odd length because if you start from V1 here, we have 1, 2, 3, 4, 5 and then we come back to V1. So it is 6 which is even here. So we have covered basic aspects of a walk, path, trail, circuit and cycle. Do try out the assignment and feel free to contact me for further help. Thank you.